Hello children. Previous videos we have seen sets and the types of sets. Now in this video we are going to see what are Venn diagrams. Venn diagrams were named after the English mathematician John Venn. Now Venn diagrams are nothing but they include your closed figures. That means it may be a circle, maybe a ellipse, rectangles, triangle. Okay, so they are the diagrammatic representation which gives the relationship between any two sets, and usually the universal set is denoted by a rectangle and its subsets they are represented by any other closed figure, and usually we take it as a circles. So the subsets of a universal set are included in the rectangle, and usually we denote that subsets by using the circles. Now see here, suppose if we have A is 2, 5, 6, 7 and B is a set containing 3, 8, 9 and 10. Okay. Now I can represent this numbers 2, 5, 6, 7 in this circles. Okay, so that numbers or that elements should be written inside the closed figure. Similarly, the set B contains 3, 8, 9 and 10. That elements should be represented inside the closed figure. Okay, usually the sets are denoted by circles. Now, for this two given set, I may take your universal set as set of natural numbers. Okay, so that set of natural numbers, that universal set is represented by a rectangle, and there I can write here n. That means your set of universal set is nothing but your set of natural numbers, and the subsets that should be written that should be drawn inside the rectangle. Okay, now since the sets A contains 2, 5, 6, 7, it is represented there in the set A, and the elements of set B are represented in the set B itself. Okay. Now consider this as an example. A is a set which contains set of prime numbers less than 10, and B is a set which contains set of prime divisors of 26. In the first case, it is a set of prime numbers less than 10. So, I'll be having prime numbers less than 10. It will be 2, 3, 5 and 7. And second set B, it contains set of prime divisors of 26. Prime divisors, that means will it be only 2 and 13? Now suppose if this sets I have to represent in a Venn diagram. Okay, now how we can? Now if we observe the sets A and B, can you find a common element there? Yes, which is the common element? 2 is the common element. So whenever two sets they have common element between them, then they will somewhat, what we can say is they will somewhat join. Okay, that common element will be overlapped, and it will be overlapped as a single element. Okay, so this set can be represented as, yes, we had A, it contains 2, 3, 5 and 7. B contains 2 and 13. Okay, the two sets they overlap over that 2, because that 2 is repeated in both the sets, so it should be counted while drawing that Venn diagram only once. Okay, so that will be the representation if any element is common. Before the what we have seen was there was no element common, so that two circles were representing that two different set itself. Okay, there was no element in common. Now we'll see operations on sets. As we all know that in a number system we have various operations. Yes, addition, multiplication, subtraction, division, right? That are the main four fundamental operations. Now, in case of sets, we are going to study only two operations because according to CBSE, now complement of a set and difference of the set, that is deleted as a deleted portion. So for us only we have to study now union and intersection of the sets. So let's begin with. So union of the sets. Now you might have heard the word union. Union means what you are doing? Union means all together. Yes, everyone will be together. That is the union. So the same thing or the same logic is behind this union of sets. So let us see what is that logic. Your point P set, it contains elements 1, 2, 3, 4, 5, and Q sets, it contains the element 5, 6, 7, 8, and 9. Now union of P and Q, it is represented by P union Q. Okay, that U is read as union. So I can read this as P union Q. Now see which will be the elements in P union Q. The elements of P as well as the elements of Q. Okay, the elements should be either the element of P or the element of Q or the elements of the both. That means what? The common elements. Okay, so elements, it will contain either the elements of P means 1, 2, 3, 4 and 5, or the elements of Q, that means again all the elements of Q should be included. But whether 5 already I have written, so no need to write that 5. It should be 6, 7, 8 and 9. Okay, so this is the set of your union set. So the union of the set, it consists the elements of first set or the elements of your Q or both. Okay, so we'll get P union Q as this is the set. So the union of two sets A and B is a set C which consists of all elements that are either in A or in B. Okay, or I can add one more, or both in A and B. Okay, now the given set of union A union B, that can be written in roster form, set builder form as roster form was just the listing. I have to write the elements. Now set builder form means it is the general rule. So A union B, I can write using set builder form as it contains X such that X belongs to A or X belongs to B. This is the definition of your union set. Okay. Now the Venn diagram for the union set is your U will be the universal set. Okay. Now two elements, its union. That means all elements of set A. So all elements of set A, that means this is the whole set. All elements of set B, that means again this is the whole set. Okay, so elements of set A as well as the elements of set B, they combine together to form your union of two sets, and hence the shaded portion with your green part, that is called, or that is the region for union of two sets. Okay, elements of A as well as the elements of B. Clear how your union of two sets will be represented using the Venn diagram? Okay. Next, we'll see some properties of union of sets. First is your commutative property. Commutative property, yes, in case of your addition, subtraction. If it is addition, what is 1 plus 2? 3. What is 2 plus 1? 3. That means what we have studied, addition is commutative in case of your natural numbers. Okay. Now the same thing in case of sets, we are going to see whether your union is commutative or not. Now see, A union B, that means it contains all the elements of A as well as of B. Similarly, B union A means what? All the elements of B as well as the elements of A. So whether both are the same. So A union B will be always equal to B union A. Is that clear? Next is associative property. Again, we had seen for the numbers. Associative property, we require that three numbers. If it is 2 plus 3 plus 5, how we write? For associative, we write it as again, that is same as 2 plus 3 plus 5. Okay, so that is your associative property. The same thing for union of the three sets. Associative, you require 3. So here it will be 3 sets. So here it is A union B union C. Now suppose if I have this is A, this is B and this is C. Now A union B, will it be, this is A I have taken, this is B and this is C. Okay. So A union B, will I have it as, this will be the set, yes, this is my whole A and this is my whole B. Okay, so this is A union B. Then then if I take its union, then whether with C, that union with C, whether the whole will I get, that means will I get it as A union B union C. Okay, this is the portion for A union B union C. Now think for the next one, LHS. LHS is A union B union C. Okay. Now in this case, bracket is B union C. So this is my B union C. Okay, this will be my B union C. Now along with this, I'm going to take your A. So whether the previous Venn diagram and this Venn diagrams are the same. So we can say what? Union of sets satisfies associative law. Clear? Next is A union phi. Phi means what? Empty set. A union phi is always equal to A. Now whether empty set does not contain any element. Okay. So suppose if I have the set as 1, 2 and 3. If I am going to take its union with 5. Okay. Now 5 does not have any element, and union means what? It is a collection of both the sets. So whether my A union 5, will I get 1, 2, 3 itself, and hence that is your set A itself. Okay. So this law, we called it as law of identity element, and phi is called as identity of U. U means universal set. Hope this is clear. Okay. Next, A union A is always A. Yes, this is the universal set. This is my A. A union A, that means this set itself. So it will be always equal to what? A. And this property is called as idempotent law. Okay. Next, U union A is always U. U is what? It is a universal set. So suppose if I have my universal set is equal to 1, 2, 3 and so on till 10 numbers. Okay. And A, I have a singleton 1. If I take U union A, what will be my set? Will it be 1, 2, 3, 4 and so on till 10 itself? That means is that set U itself. Okay, that means, can I say, if we all know that your universal set is the bigger set, A is subset of U. Okay, that means if A is subset of U, then can I say that U union A will be always U? Universal set is the biggest set. In general, if I say if A is subset of B, what will be my A union B? Yes, which is the bigger set? It is B. So whenever A is subset of B, your A union B will be equal to B itself. Now the next concept is intersection of sets. Now see what are the two sets 1, 2, 3, 4, 5 and the Q set 5, 6, 7, 8, 9. Now intersection, that means there is the common elements. Okay, it will consist of only common elements. Now if I observe these two sets, whether 5 is the common element, so intersection of P and Q, it contains only what? 5. And see how it can be represented. So intersection, it is represented by P this here. Just tilt your U upside down. So it will be P intersection Q. This you are going to read it as P intersection Q. If it is written like this, it is P union Q. Okay. I got, in this case it is singleton 5. Okay. Now intersection of two sets A and B is a set of all those elements that belong to both A and B. That means they are common to both A set as well as to the set B. So if I want to write into set builder form, I'll be writing it as it contains X such that X is the element of A as well as X is the element of B. Okay, I'll see how to represent your Venn diagram. See, these are the two sets A and B, which will be the elements common to both your set A and B. It is nothing but this portion, because this portion is the common part. So that part is your intersection part. Clear? Now see, if you have been given C as 2, 4, 6, 8 and D equal to 3, 5, 7, 9, can you find any common element? What will be my C intersection D? Yes, C intersection D, what will I have? 2, is it common? No. 4, no. 6, no. 8, no. 3, no. 5, 7, 9, no. That means there is no element common in the set. That means whether the set contains no elements. If the set contains no elements, which is that set, or what is the name of that set we have studied? That is nothing but your empty set 5. Okay. So if there is no common element between the two sets, then the sets are called as disjoint sets. Okay, disjoint. That means they are separated. They are disjoint sets. Clear? So here we have got C intersection D is equal to 5. Now suppose if I am going to represent this as a Venn diagram. This is my C and the other set is my D. Now do I have any common element? No. So how should I draw that D? I have to draw that D separately itself. Since there are no common points, there won't be any overlappings. Okay. So that two sets will be your disjoint sets. So you'll be getting the Venn diagram as this. So the next till this we have seen. Now see the distributive law. A intersection B union C, it is equal to A intersection B union A intersection C. See, why it is called distributive? Since if it is A into A plus B or B plus C, how we write this as? We write it as A into B plus A into C. Okay, that means just I distribute that A to B and C. Same case, here it is in A intersection B union C. So it will be A intersection with B in between union A intersection with C. So this distributive law we will see how we can prove using your Venn diagrams. Now, can you guess what is this figure? Okay, what is this figure you will have? This shaded region. This is my B and this is my C. That means I have shaded B and C. That means that is nothing but your B union C. Okay. Now if I take A intersection B union C, that means common part to A as well as to B union C, which is that part, whether this will be the part, okay, common to A as well as common to B union C. See how will, yes, so that will be the part. Okay, so this will be my LHS. Now consider your RHS. RHS first is A intersection B. So this is set A, this is set B. Common part to both A and B is represented by that green. Okay. Then the next is I am going to take union with A intersection C. A intersection C, will it be this part? Okay. This is your A intersection C. Then if I take union of A intersection B, this was my part. Your A intersection B was this part. Okay, if I take union A intersection B and A intersection C, will I get the same part itself? Yes, and hence the distributive law, it is verified using a Venn diagram. Hope the concept of Venn diagram it is clear. Okay, in the next video we'll be seeing problems regarding Venn diagrams. Okay, that is problems regarding your union and intersection.